Hello guys, myself Meet Nagadia and today we'll be doing project on time series analysis. So basically we'll be doing Bitcoin price prediction using LSTM. So here is another deep learning project that we will do. So basically here our flow would be this. So first we'll try to understand a little bit of LSTM, then we'll import our necessary libraries that are required, and we'll also load the dataset. I will tell you how you can download this Bitcoin price dataset, and then we'll do a little bit then we'll load our data set, and then we'll do a little bit of EDA so that we can better understand our data, and then we'll try to build our LSTM model, and then using the data that we have collected from the training and testing we'll try to predict it, and then we'll try to evaluate our model to know how good it is. And what we can do is we can also create one more topic here, which would be fine tuning the model. So here you can tweak the hyperparameters to get what the model will predict based on the tuning you have done, and then there would be a final conclusion. So uh, let's start with it. So this code is available in the description down below, and I'm using Anaconda for it. You can use anything, Google Colab, or you can also use Anaconda. So basically, what is LSTM? LSTM is long short-term memory, as the full form goes, is an artificial recurrent neural network used in the field of deep learning. Unlike standard feed-forward neural network, LSTM has feedback connections. It can process not only a single data point but also an entire sequence. So here also our data would be sequential, so we are using LSTM. So LSTM are often referred as fancy RNN. Vanilla RNN do not have a cell state. They only have hidden states, and those hidden states serves a memory for RNN. While LSTM has both cell states and hidden states. So we have an advantage of LSTM over RNN. So this is how the LSTM structure architecture looks like. So moving on, so what we'll do is we'll just mm, restart and clear output. So we'll start one by one. So first of all, here are all the required libraries that we need. So OS, Panda, NumPy, Mat, Datetime, and Matplotlib. So these are all the basic libraries that we need. Then for the evaluating, we need few libraries which are available in sklearn. So it will be an time series, so we cannot use uh, matrix such as accuracy, because since it is an time series, we have to calculate the mean square error, absolute error, R2 score, that is R square score, mean Poisson deviation. These are all the things that we can do. So we will import this lib such things from sklearn.metrics. Then we'll build our model using TensorFlow, and we'll have first sequential, dense, dropout, and then LSTM from TensorFlow.keras.layers. Now for plotting, um, we can do one thing is we can cut here matplotlib, and we'll have written here. So for plotting we need matplotlib, as well as we'll go for plotly, which is interactive way for plotting things. So we'll just run it. It may take some time. So basically, here we are using TensorFlow. So if you haven't installed TensorFlow, you need to create an virtual environment for an Anaconda and then install TensorFlow so it doesn't mess up with the other libraries that you have. So I have already created an environment, and I have installed TensorFlow on it. So now we'll load our data set. So basically, we'll load our data set, or we can say we will download our data set from Yahoo Finance. The link will be in the description below. So here this is the website of Yahoo Finance, and I have searched for Bitcoin price. So currently the price I am which is showing here is USD and not Indian currency. It is US currency. And what we will see here is the current amount, what is the current price of Bitcoin. And if you see here, you will see summary, chart, conversation, historical data, and profile. So in historical data, we can select how much of time period we need for the data that we want. So if I just want one day, it will, show me just one day. So this is of the current day. So it is from 18 to 19. So it will show 2 days. If I want for 5 days, I just have to click here and then apply. So it will show me the rest of the things that I need. So we can just do max. We also have like for 3 months, 6 months, a year, 5 year, and max. So I'll just select on max and see how much max does it have. So as you can see here, it contains data from September 17, 2014 till today, that is 19 February 2020. So I can just click on download here and it will start the download, and as you can see it has already downloaded. So I'll do is I'll keep this data, that is keep this CSV file into the directory that has my this prediction. Or you can just, if you are using Google Colab, so you can just upload your file and then give the file link, file path to where the file is stored. So here as it is my local, so I'll just have to give the file name, which that it was btc usd.csv. Since it is a CSV file, we can read it using pandas, and I have created a variable here that is main.df that will store the data for us, that will read the data from CSV and store it. So now what we'll do is we'll just try to check what is the start date and the end date. That is, here I have just printed the total number of days present in the data set. So we have total 2713 days present, that is from 2014 till 2000 September 17, 2014 till February 19, 2022. So this much days, and these are the columns that are available. So I'll just did the shape, so we get the tuple format, and I will be printing head that will be giving me the first 5 columns, rows of the data set. So here we have date, open, high, low, close, adjust, close, and volume. So what here we will be doing is we'll basically predict the closing price. Will be predicting the closing price of the Bitcoin. And for giving you information, so about the columns, the date column, as it says, it is the date that is, for example, let's say first, that is 2014, 09 means 9th month and 17th date. So it is containing the format of year, month, and date. So open means the opening price of the Bitcoin. High means what was the high value in a present day. For example, in here, what was the highest value that it has reached? It was this. And low is just the opposite of high. And close means what was the closing price of Bitcoin on that day. And this is just the adjusted close, and this is the volume. So what we require here is mostly the close and the date. And if I talk about, then we'll just need we just need the closing price, as it is time series. So we don't need any other requirement. So I'll just quickly print the last 5 as well. So it will give me the last 5, which will be the current date, that is 19th of February. And info of the data frame will give us the info, so what are the column presents, and what it is null type and its data type. So main df dot describe, it will tell me the count, mean, standard deviation of the columns. So now checking for the null values, it is one of the important part of the data. So means data pre-processing, where we check whether the data that is present with us has the null values or not. So for that we'll just use um, data frame name, that is we have used here main df dot is null dot values dot sum. So it will give me whether it has the null values or not. So as it says that we do not have any null values, so null value is false. And if our data set had any null values, so we can use this code which will give the which would remove the all the null values from the data set. It would take that row which contains the null values and it will drop it. So let's see the final shape. Since we did not had any null values, so our shape would remain the same. So now we are doing EDA, that is exploratory data analysis. It is completely optional, since we just want to see how our data is. So we are doing a little bit of experiment, not an experiment. We are just little bit exploring our data to better understand it. So what I'll do is I'll print the starting date and the end date of the price of the date column. Sorry. So here we have starting and the end date. We knew that from the data set itself, but it is from the code that we are seeing. So now what we'll do is we'll start our analysis. So here basically what we are doing is, let me just create a markdown here. We are doing the analysis of year. Let's say first is 2014. So we'll write here 2014. Analysis of the year 2014. So here what we'll do is we'll first take the date of the column of the our data, and we'll convert it into the date time. So this is our code. Sorry, this is our code. Just a second. Yep. So first of all we'll convert our data date of the data frame to the date time using pandas. And then what we'll do is we'll create a variable name year. So y stands for year, y underscore 2014, which will contain the data from the year 2014. It will only contain the data of year 2014, where rest of all will drop it. So what we'll do is we'll just create a variable, and then we'll use the dot log function, and then we just want our starting date from, as we know that our starting date of 2014 was from 1709. So we'll just take that, and our end date would be the 31st December of 2014. So here it is. So then we'll just drop the adjust close and volume. So we just have the date, open, high, close, and low. This is all that data that we have. So now what we'll do is we'll group them together, and we'll try to get what was the opening and close. So for that what we'll do is, as you can see here, we have date, we have open, and we have close. So we'll mean the data. So for example, whatever the data we had of the open and close from the starting of the month to the end of the month, we'll take the mean and we'll display here. So as we can see that we do not have any data for January, February, March, April, May, June, July, August, because we don't have data. That's why it's showing us none. And from September, October, November, December we had data, so it is showing us the mean value of all the of the open price and the close price. So note that we only have few months in 2014, so the rest of the months are none. So now what we'll do is we'll create a bar chart. So I'll explain this later. So let's look at the bar chart first. So this bar chart will tell us what was the stock opening price and close price of the average of each month. So this was the opening and close price, as you can see here. For the red one, it is stock open price, and for the right close one, it is orange one, it is the close price. Also, we don't have any data for January, February, March, April, May, June, July, August. So we don't have any bar charts bar for this month. Now what we'll do is we'll sum up the um high and low. Again, this was for open and close. Now we are doing for high and low. So what we'll do is it is very simple. So we'll just take a look at it, and now yep. So here what we did is we are using plotly here. So we'll write fig is equals to dot figure, and then fig dot add trace will we need the bar chart. So we are taking the bar function here, and we are giving x is equals to monthwise dot index. It will give the values of the here we have grouped them by the date, and we'll taking the open and close mean. So we'll give the values of x, and y will be just open, and we are giving it the name stock open price. We can also write, rather than stock, we can write bitcoin bitcoin open price and bitcoin close price. So this is just the opposite one, where then we are setting our um, color here. Marker underscore color is equals to crimson. So we are just putting the color. So same as with now with the close one. We had done for the open one, then we are doing for the close one. So here in close again one monthwise dot index, and now we will be giving our label as close. So we have given the light salmon as the color, and name will be Bitcoin close price. So then we'll say the bar mode as group because we want to, and then we'll say x-axis underscore tick angle is equal to -45, and here is just the title that we have given. So this is the one. So here is again what we'll do is we'll take as it is high and low. So what we need to do is we'll create a new uh, label for here, new data, because we before one was the mean, so we don't require that much. We just require the mean value, but here we need high as well as low. So for that we will require mean as well as max. So here we'll be creating our mean using just the group, and we'll just say low for mean, so we will get the lowest, and for high we'll just use max so that we can get the high. So here is again the same thing. Then we'll use fig dot go dot figure. So we'll go for bar graph, and again what we'll do is we'll write the monthwise underscore high dot index. So we'll get the values of the high, and by label which is monthwise underscore high, and then we'll write the name as Bitcoin high price, and then we'll give the color. So here I have provided the RGB color, and same is for the Bitcoin low price. So basically we have again gone for bar chart, and will provide the values that are required here, and name will be the Bitcoin low price and RGB color. And then we'll just write the fig dot update, and bar mode is equals to group, since we want a group bar chart, and then we'll provide the title for the bar chart, that is month-wise high low Bitcoin price. So now what we'll do is we'll did this for the um, year 2014. So now let's sum it up so that we can know that what was the overall trend of the year in 2014. So basically we'll just take name and it will have let's say Bitcoin open, Bitcoin close, Control Z, Bitcoin close, stock. Instead of stock it would be Bitcoin. It will just have the labels, that is Bitcoin open price, Bitcoin close price, Bitcoin high price, Bitcoin low price. So now what we'll do is we'll create the line chart. So this is the line chart and we'll give all the parameters from high, low, close and open. And we'll give the label of the date as date and value as stock value. So this is the we'll say Bitcoin analysis chart, and we'll say Bitcoin parameters. Okay, so as we run this, we'll get that for where our data starts, that is from 17. So as we hover over the our line chart, it gives us the value of the current Bitcoin price, whether it is open price, close price, high price or low price. So this is how we get. If we zoom, so here we also have the zoom option, so we can create a zoom. So if we want to zoom, so we can zoom here, and this is the ability provided by Plotly. So we can get to know about what is the price of here as we hover over here. So this was the analysis of 2014. We can do the same thing for 2015. We just have to change the date. So here the date would be 2015 January 1st until we get the date of January 1, 2016. So we'll just run all the things. So here is the first. Yep. So what we'll do is we'll first we'll get the data. So here is our data. It is starting from first and it is till 31st, and we have 365, so we don't have any null values here. And this is just the open and close mean that we have. Then we'll just put the month-wise comparison chart. As we can see here, we have from January till December, and this is the open and close price. So almost for every, we have almost nearby values that we can see. We can just hover over, this is the Plotly, so we can just hover over to see what are the price here. So we'll just skip for it as of now. So this is for the high and low stock price. So instead of stock it would be Bitcoin. So again now we'll get the complete analysis of the whole year. So as we can see that for as of now we can see from January till December, as we can hover over here. So it is a quite of bit trend, but we don't see any pattern that it is continuing. So it might be tough for using a linear regression here for doing this task. So this is for the analysis of 2016. I'll just going to fast forward because it is all the same thing, just the data changes. So our plot would be a bit different. This is the whole analysis of 2016. As we can see, there is a huge hike here where its price is almost about 777 USD dollars. And then we'll move on with analysis of 2017 year. And in 2017 it nearly reached 1k, and it went up till 15k. That was a very huge hike. So as we can see here, it nearly went up till 20k. That was a huge hike. And if you see here, in the starting months, it was just about near 900, but till the end, it went up till 15,000. And when it is was on its peak, it was about 20,000. So now we'll just get the analysis here. So from there, it went down from 13 till it was about 3,000. Near 3,000. I mean near 4,000. So now we'll get the high and low price. So it was nearly about 17,000 and then it came back again at almost 4 to 5,000. So this is the chart. It went high and it went low really quick in 2018. So this is all the overall trend and we'll just do for the 2019, and as we can see it was about 10,000, and then again it actually in the starting it was nearly about 3,700 and it drastically went up in the upcoming months, and then again on December it went up to 7,000. So this is the stock high price. So here we can see here the highest was in the year was in June, and it was about, sorry, it was about 13,000, nearly 14,000. So the trend here is this. It is very low when it was in the start, but in the June the trend quicked up and it nearly reached 14,000, and by the 2020, let's see what was the analysis here. As we can see in 2020, it was starting at 8,000 and it nearly reached about 21,000 by the end of the year. And the highest was in December. It really reached about 29,000 in December. That is the highest price it reached in December. And this is again the overall trend of the year 2020. Now we'll quickly do for 2021. So in 2021, it went from 34,000 to almost about 61,000. So here we can see as the year increased, the price of the Bitcoin also increased, drastically increased, and the highest it reached was 70, near 69, $70,000. So this is the trend. It quickly came up and again down very quickly by the end of July, and then again September it went up, and we see a little trend here also where it quickly evacuated to 66,000. So this is overall of 2021. So here what we'll do is we'll write a markdown here. So here this markdown is of year 2022, analysis of year 2022. So now it is just the same. We'll have, as we can see, we just this is the second month of the year of 2022. So we just have the data from January and February. So rest of all will be as null, and we'll just get the first 2 month price. So rest of will be blank here as well. So this is the highest and lowest. So highest it was 47, nearly 48, and this is the overall trend from just 2 months. So from 48 it went near 40, 41. So now what we'll do is this is the overall analysis of 2014. So overall analysis from 2014 to 2022. So where did the Bitcoin price was first, and what was it on the last from the current date. So this is our normally date, open, high, low, close, and we'll just do the open and close, and here we'll get the overall trend of our data. So as we can see, it started on 2014, but it was not that quite high enough back in those days. But as we can see, the little trend in data from 2018, where it reached about 20,000, and then it again quickly got back to around 7,200, and then in the year 2020 it again got very high, and in 2021 it gone very high, about 74, and in 2022 in January it really went up till 68,000 US dollars. So this was the overall trend. So this is basically a small EDA. So here we can do a more detailed analysis of how from where we started our analysis of the year. So this is just a small analysis. So we can get our data. We can visualize our data, and we get the data a little bit more info from it. So as we can see here that our data is fluctuating very much. So we'll deal with it later. So now let's move to the next step. So next step is building LSTM model. So for that, what we'll do is first step is preparing data for training and testing. So we have our data, we have just done a small pre-processing step, that is checking for null values, and if it had null values, then we'll just drop the rows. So now here what we'll do is we'll just consider 1 year of data for the training, and we'll just split it into the training and testing. So why am I choosing 1 year? Since the Bitcoin price, as you can see here, it's very much fluctuating between the years. So if I take the data from 2015, it would be too much. Like from starting, it was just about 300, and then in the year 2021, it went up till 70,000. So our model will be confused from data like this. So we are just putting it and cut here. So we'll just take from year 2021 till 2022. 1 year would be enough so that we can train our model. We can also do from 2014, but you know that might affect the accuracy of the overall performance of the model. So we are just doing one thing. We are just taking the 1 year of data. We can try experiment using 2 years or maybe 3 years to get what the effect is on the accuracy. Since the Bitcoin price has drastically fluctuated from $200 in 2014 to $1,500 in $15,000 in 2018, and $3,000 in 2019, these values are approx. So we just consider one value to avoid the type of fluctuation in the data. As we want to predict the close price of the Bitcoin, so we are just considering the close and the date. So here is a small typo. So we'll just create a variable, and we'll store the date and close price from the main data frame that we had, and we are just printing the shape that we are just putting how much value do we have. So this is just the starting. So we just have our normal 2713 rows and two columns. The columns are date and close. So now we will try to see what is the overall fluctuation of the data. So here again we are just using our plotly. So this is the close price. Above we just saw here is again the same thing, but we had here open, close, high, low. So if I try to zoom it, we can see that it contains, okay, just a second. So as we can see here that it has green lines, red lines, purple lines. So it is just the same thing. And so we are just putting here the close price. So now what we'll do is we have plotted this to see the trend in the close price. So as you can see, if I take data from here, so our model might affect its accuracy because it will think that it is not in the proper trend. So what I'll do is I will just take 1 year of data. So for that, what I'll do is I'll take our variable, that is close df, and we'll select the date in it, and it should be greater than this. So it will give us the values that are greater than this, that is our 1 year of data. So we are copying it and will print what is the total number of rows that we have. So we have total of 365, which is what we need, and this is the start date and the end date. So here we have taken 2 years. Okay, so just let me. Okay, no. I'm sorry. We have just taken the 1 year. Actually, we have the date in format of year. So 2021 is the year, 2 is the month, and 20 is the date. So this is how we have our starting, and this is the close price for it. So this is how our data set looks like. So we'll just plot it again so that we come to know how our data set is looking. So we have our starting data from, okay, it is not zooming here. So we have our data from 20 February till 19 February 2022, 18 February 2022, and this is the overall trend that we can see here. So because there is so much fluctuation, we first need to normalize our data. So what is normalization? Normalization is a technique often applied as the part of the data preparation in machine learning. So our main goal of normalization is to change the values of numeric columns in a data set to use a common scale without distorting the difference in the range of values or any losing any information at it. If we lose the information, it is of no use. So we are using here MinMax Scalar for it. So what it does is for each value in a feature, MinMax Scalar subtracts the minimum value in the feature and then divide by the range. The range is the difference between the original and the maximum, or original minimum and the original maximum. The min-max scalar preserves the shape of the original distribution. So what we'll do is we'll first delete the column that is date in the close df. Why we are doing it? Because we don't need date, we just need our closing price. So we'll delete the date, and now what we'll do is we'll create a variable scalar and we'll initiate with it with the min-max scalar, and then we'll fit it with the transform method, and as we have only one, so it will be containing only the gross price of the Bitcoin. So we'll execute and it will just return us the same thing. So if I print close df, so it will give me the array. So this is how the normalized data looks like. So now what we'll do is we have our data set ready. We have already pre-processed it, and now what we'll do is we'll split it into the training and testing. We can also create a validation set here, but as of now we'll just create training and test. So we'll keep the training set as 60% and for testing would be 40%. So for that we'll be just multiplying it by 60 to get our training size and test size, and then we'll use the lock function so that we can get our data, training and test data. So by implementing this, we'll get the train data as 219 and our test data would be 146. Training would be 219 and testing would be 146. So now what we can do is we can transform the close price based on the time series forecasting requirement, and here we'll be taking the timestamp as 15. So what we'll do is we'll create an we'll convert the array of values in the data matrix. So for that what we'll do is we'll create a function that is create dataset, and then we'll pass the dataset and the timestamp. So here we'll be taking then data x and data y, and we'll create the empty list for it, two empty lists for it. So for range in length of dataset minus timestamp minus 1. So then we'll take the data, we'll take another variable and we'll say let's say data, and then we'll take the ith value from I value and from 1 plus timestamp. So this is how it will be. Then what we'll do is we'll create the timestamp, and then we'll initiate our timestamp which is 15, and then we'll pass the data set, and then it will create a data set for us. So we'll get our x train, y train and x test, y test. We did this because we just had our only close price, so it will create the data, for example 0 1 2. So it will be 0, so next would be 1, and then again 1, then it will be 2 in this format. So we are just reshaping it, and now we will build our model, that is LSTM model. So for that what we'll do is we'll take a variable say model, and we'll initialize it with the sequential, and then we'll add layers. So first layer would be LSTM, and we'll add dense layer. So this is a small model. We are not creating a huge one, so it just contains the LSTM and dense. We can tweak it, we can add more layers in it, but as of now we'll just keep it simple. So this, and now what we'll do is we'll create a variable called history, and it will store the history of the model. So it will store what was the loss, what was the well loss for it, and we'll give the validation as validation data as our testing data, and we'll give 200 epochs, and batch size would be 32, and verbose is equals to 1, so it will tell us what is the validation loss and what is the loss. So we have to wait for a few minutes to get this executed. So as we can see that we are getting a loss of 0.18 and a well loss of 0.29 or something. So it will gradually decrease. We have already done with around 74 75 epochs. Depending upon the GPU you have, it will take time. If you are working on CPU, then it would take more time, and if you are using a GPU, then it will be taking less time. You can activate GPU on Kaggle notebooks or Google Colab, where they allow you free GPU for your notebook for particular times. So we are about to complete the epochs. We have almost done with 194, 195, 197. Yep. So we are done. So our loss at the end is about point 0.0027 and 0.0025. So we can say that our model really did very well here. So now we'll just plot the, we have already imported it. So we'll remove it. We'll just print, we'll plot the well loss and the loss that we had. So this is how the plotting goes, and we'll try to predict the performance. So we are just printing the train predict shape and test predict shape. So what was their prediction step shape and our model evaluation. So as we have predicted, so now what we'll do is we'll check the evaluation for it. So we'll first transform back a data from the original so that we can evaluate. So we have few evaluation metrics here, matrices here, which is RMSC, MSC, and MAE, root mean square error, mean square error. So we'll plot for training as well as for the testing. So for train data RMSE, we'll just take the square root of mean square error and origin. We'll first give our original y train and then our predicted, that is train underscore predict. So this was for the prediction of the train. So same we will be doing for original underscore y test, and then we'll give the test underscore predict. Here it is train underscore predict, it is y underscore predict. So we also have done the variance regression score. So this is the variance regression score for the training as well as testing. We also have R score for regression. So here it is. And finally we have regression loss, gamma deviance regression loss, and mean Poisson deviance regression loss. So these are those values. So here we'll just basically give our original y train values and then we'll give the predicted ones. So for train it would be original underscore y train and then the train predict. For test data it would be original underscore y test and then the test predict. Same for the testing one. So the comparison of original Bitcoin close price. So here it would be a Bitcoin close price and the predicted one. So now we will print. So here we have plotted our the original value of the closing price. So basically the blue line that we can see here, it is of the original one, and then the orange one we can see here. Okay, so I zoomed here. So this is showing us the orange will be showing us the predicted close price. So on the training data set that we have given it, and on the green one it will be giving us the test price test price for close one. So now what we'll do is we'll do one thing. We'll predict for the next 30 days. So as we have prepared our model for the price prediction, we have already trained it using our training data and we have validated it using the test data. So now what we can do is we'll give model a command to predict the what will be the price of the Bitcoin for next 30 days. So for that we'll first create the data for it. So we'll create X input and then we'll give just the training data, test data that is, and the length of it. And from we'll create an array for the timestamp. So here it will be, and we'll create the predicted days as 30 since we want 30 days, and we'll just print it. So we'll get our we'll also reshape it and we'll also give the prediction of it for the 15 for the 30 days. And what we'll do is we'll create here the timestamp of 15 as well as 30 days. So here y hat is equals to model dot predict. Our input would be then the sequence that we have created, and so now we will plot it. So this is how it would look like. So first it would be 1 to 15, and for the next 30 days it would be from 16 to 45, and then we'll just plot it. So this is how our 15 days would be looking like, and then it would be predicting the next 30 days. So it is saying that it would be around 40.09. So as we can see here, okay, it is nearly about 39.9. So it is basically having few errors, but it is quite considerable model if we see, because we have just trained it on 1 year. So we can do is we can tweak the parameters for it. So for example, we can say take the data from 1.5 years so that we can get a little bit better accuracy than this. So as we know that the Bitcoin price is very fluctuating because of many factors, not just one. So sometimes it may happen that model will predict an value that should be the actual value for it, but because of any influences, the price may be affected. So this is the project of LSTM, and so what we'll do is we'll plot the entire curve. So this is how the whole prediction curve would look like of the gross price. This is the timestamp that we have given. So, alright guys, this is the project of LSTM, where we have used Bitcoin for price prediction on closed, its closing price. Here we have done the prediction on closing price. You can do the prediction on high price or the low price or the open price. It depends upon us. We can play with the factors on it, or we can also predict the adjacent close price, which is one of the same, as we can say that. And that's all for today guys. I know the video is too long, but hope you have enjoyed. The notebook link will be in description. And yeah, that's it for today guys. Hope you like this video, and let me know if you have any suggestions to how to fine tune this model. So we'll be updating this. So the notebook link will be in description of the Kaggle notebook, as well as the GitHub link. So that's it guys, hope to see you in next one. Thank you, goodbye, happy learning.